uh, introduce yourself and let us know where you guys are from, what you're doing, and which part of the country you're from, and what made you excited to attend this webinar today, and then what's something that you're really looking forward to learn from Shreyansh today. Please introduce yourself, let us know your name, what company you're working for, your designation, and which part of the country you're from. And I'll quickly have a look at our live, if we're going live or not. We're going to wait for 1 to 2 minutes, guys. Will not take a lot of time. Thank you for being on time, and that on weekends. Well, that shows the zeal of the learning. And just a quick 1-2 minutes, and then I think we'll be good to start with our webinar. Okay, we do have people waiting in on LinkedIn, Shreyansh, so we'll not make people more wait on there. We have 50 people and watching us live, so I think we can get started.
Sure.
Okay.
Perfect.
So hello and welcome everyone. Hope you're keeping well and staying safe. This is Hafsanjum and I am working as a community executive at Recro, wherein we are working towards building an exclusive community for developers to help you get connected with like-minded people, build your network and grow professionally. So those who don't know about what Recro is, it is a developer-focused platform helping developers to meet the right opportunity by connecting them with fast-growing startups such as CureFreight, Udaan, Swiggy, Dunzo, etc. So welcome to Recro Talks today. And today we are going to discuss on system design and how you probably don't need microservices. And our guest speaker for today is Shreyansh Pandey. He is a consultant software and a security architect. Shreyansh has been working for almost 11 years. He worked towards crafting software systems and that powered some of the biggest and the smallest countries of the world. He's skilled in distributed and high-performance security intrinsic systems for companies from a variety of verticals, from finance to healthcare to risk. We're very happy to have you, Shreyansh. You can go ahead and say hi to the audience.
Oh, thank you so much, Anjum. Hello, everyone. It's an absolute pleasure and a delight to be here presenting. And I apologize in advance for some of the absolutely terrible jokes I'm going to crack. So please don't raise your hands for that. But yeah, it's a pleasure here. It's a pleasure here. Yeah.
Yes. So before we start, I would like to make some announcements. You can post your questions in the question section. For the people who are joining us on Zoom, you can see Q&A tab on your screen on your left-hand side. So please post it in the question section because we don't want to miss on your questions. And the chat section is just for the normal informal chat. And we'll be taking up at the end of the 15 minutes of the session. And we will be rolling out a feedback form in between. So please do answer that and let us know what did you like the most about this webinar. And if you want Shreyansh for our next series of a different version of the webinar and different topic, we'd love to have him more for the webinar. And keep your notepad handy, and whatever you're learning from today's session, please post it on your Twitter or LinkedIn along with your key learnings and key takeaways, what you love the most. And we'll be more than happy to see your learnings. And do tag Shreyansh, do tag Recro, and do tag me in your post, and we'll be good to go. I think we can get started, Shreyansh, and let me know if you're sharing your screen.
Sure. So I'll very quickly share my screen here. Okay, folks, please don't judge me for my PowerPoint skills. I am not too good at it. But right, I think we already have a question. Oh, yeah, great. I think so it's visible, if I'm not wrong.
Yes, we can see it here.
Perfect. All right. So can I just kick in? Can I just start it?
Yeah, definitely. I think we can go ahead.
Right on. All right. So in this conversation, folks, we're discussing, well, the topic is you probably don't need microservices. And I'll give you a little bit of a background from where I'm coming with this conversation here. Over the last couple of years, what I've seen is, a new startup or an old startup, whenever we are discussing technology, whenever we are discussing architectural patterns, one of the first things which sort of pops up is that, let's go with microservices. Let's go with something which is new in the market. And very often I have seen that the primary reason for going with that is because it is new in the market. And that has slowly and surely become a fad. And I'm not by any means sort of saying that microservices are bad. They're absolutely fantastic, but they're fantastic for a very specific use case. And that use case isn't as technical as a lot of people think it is. So in this conversation, what we'll be doing is we'll be going through we'll be essentially stepping in the shoes of, let's say, a founding engineer and trying to figure out how do you build microservices for a startup in the first place. And along with that, we'll be discussing some of the challenges, some of the questions, some of the choices you have available in front of you, and we'll see how quickly it sort of adds up, especially if you're a small team. Further, we'll be discussing what all is it that we can do to sort of, get best of both worlds. Can we figure something out which is, let's say, independently scalable, while at the same time it's not a hassle to manage like a microservice where you need like some subject matter experts for a lot of things you're doing. Finally, we'll also be sort of giving a tip of the hat to the microservices themselves, where we'll be discussing what is it which makes them so special and where is it that you can actually use them. Like I said, the reason for that usually isn't as technical as some people think. So we'll be diving a little bit into that. So with that, I would like to kick off this conversation. Right. So I'm Shreyansh, and Anjum, thank you so much for the rather lovely introduction. I wouldn't really say a lot about myself. I've just had the opportunity of working with some of the coolest companies, both in India and around India and the world. And in that, I have learned quite a lot. I'm a self-taught engineer, which basically means that I have failed more than I remember, and I have crashed more systems than I would wish to accept. So what that would translate into is that I have a lot of learnings, and they have come as 3 a.m. Pager duty notifications to me. So I'm trying to distill all of that down into something which might be useful and beneficial for a lot of you. In general, there isn't really any constraint which exists for understanding a lot of what we are talking about in this conversation. I will be giving a general introduction of what we are trying to do. And I would like to, sort of steer away from a lot of the jargons. If there is anything which doesn't make particular sense to you, feel free to just drop in a question and I'll be more than happy to answer. Yeah, so I already said that I architect and build large-scale systems, which is a lot of fun. It's not a lot of fun if you have to wake up again, like I said, at 4 a.m. in the morning. And I have a couple of social media profiles. I'm not really active there apart from LinkedIn because, everyone needs a job. But apart from that, I have Twitter and GitHub. So feel free to follow me there if you would like to hear more of this absolutely lovely voice in the future. And if you note, before we, of course, kickstart this presentation, I'm trying to make this as interactive as I possibly can. So feel free to drop in questions as and when you prefer. I would answer them once I've finished talking about a topic or a conversation, and I'll pick them up. Secondly, we'll be following a 40-20 rule, which essentially means that I'll be talking for around 40 minutes around the content of this presentation, and I'll leave the last 20 minutes for you to discuss absolutely anything you have in mind regarding the conversation topic for today. And lastly, I have a very bad sense of humor, for which I apologize at the beginning of the conversation. But again, I apologize. So we'll be discussing this entire journey in 4 basic parts. We'll be discussing what microservices are. We'll be discussing the decision paralysis associated with microservices, both when it comes to figuring out how is that you want to create and structure microservices, and also how do you deploy them. And lastly, we'll be discussing what is it that you can do if you don't want to have these conversational overheads or operational overheads, when creating a service or a product. So a very quick introduction to what microservices are. Microservices are something very, very simple. They're extremely tiny services which do one thing, but they only do that one thing. And they do that one thing really well. An example of this can be something like, let's say, an authentication service. The entire responsibility of that service is to ensure that, let's say, Shreyansh Pandey, do we know this user? Yes, we do. Let's give him a token. That's something which an authentication microservice would do. You can also add authorization, which would mean that can Shreyansh Pandey, let's say, access funny cat memes online, something along those lines. Like, do I have access to a resource in general is authorization. And the reason why I'm picking this up is because this is one of the best examples of something called context isolation, which basically means that this one authentication microservice is responsible for just one thing, which is figuring out who the user is, and finally, if the user has the ability to perform certain actions. So that's that. And secondly, there is something called coupling. Coupling essentially means, in a way, you can think of it as how dependent service A is on service B. So we say microservices are loosely coupled, which essentially means that there isn't that tight of an integration between them. We try to abstract these conversations, or we try to abstract these interfaces as contracts, which means that, a service A, my authentication service, will be giving you these 4 functions. These 4 functions will accept these 4 parameters. As long as you give me this function name with these parameters, I can guarantee you that this is the kind of response you will get. Which makes things quite nice when it comes to working with microservices. Let's say you wrote something in a language like, let's say, Java, and recently, because of whatever reason, you've decided to migrate to something else. As long as the contract holds, the programming language itself shouldn't matter. There are some terms and conditions which come with it. For example, how would these microservices interact with each other? Are you sharing any code, etc., etc.? But in general, it means that they are interoperable simply because of the fact that they have a contract between them. Now, finally, we get to the appeal. Why is it that a lot of people want to go with microservices in general? And the best way I can describe this is, there is a lot of buzz about microservices. It's been one of the, I would say, newer topics of conversation in the industry. And I have seen a lot of people use it simply because investors thought that this is the latest tech to use. I'm not taking names, I'm not saying anything, but this is something which we have seen in the past. We've also seen that just to sort of incite new players, or just to give that competitive edge that we're technologically advanced, a lot of people have used microservices. A similar argument can be made for AI ML back in 2015 and 16, and blockchain like a year or 2 ago, where a lot of people were implementing them for no technical reason apart from the fact that it was the new fad which people wanted to be involved with. The second is that it sort of decouples everything, if that makes sense. What that essentially translates into is that you have this like one unit which can do a lot of work. And it can do that, that one work pretty nicely, which means that you can have you can play with that quite a bit, considering the kind of technology you have in the middle. Like, let's say you have 2 services which want to communicate, an auth service and a user service. You can have multiple versions of that user service running in parallel, as long as, again, that contract is fulfilled. And you can do a lot of experimentation with it, which means that there isn't a very strict coupling you have on the actual services, but rather you have a coupling on what is the contract. What can they speak? What can they understand? What can they say? Which is recent. So what we'll do is that we'll sort of take an example, right? We'll take an example of a new startup we have come into. Let's consider that we're one of the first engineers. We have to make this large decision of deciding whether or not we have to go with microservices. Ultimately, we decide that we do, right? So what happens there? Let's say we choose a programming language. Absolutely any language you prefer. It can be Go, Node, Java, whatever you prefer. With these languages, there is a very high chance that you would be choosing a framework, at least initially. So, Spring Boot for Java, or Gin for Go, or I don't know, Express for Node, for example. You've chosen that, right? The next thing you need to discuss is, how will these services communicate with each other? The simplest way to get started would be just to use something like a RESTful API, where each of these services expose a RESTful API, and they can communicate with each other using simple HTTP calls. Fantastic. It's quite simple, works, gets the job done. Then what about databases, right? So I have users, and let's say I'm building something like, I don't know, a hospital management system. I'll have an authentication service which will be responsible for validating and creating users. And I will have, let's say, a patient service which will be responsible for associating additional patient records to that particular user. In these situations, how would you decide where the ownership of the data lies, right? Is it with the user service? Is it with the patient service? Or is it some form of, a garbled mess, which we'll have to later figure out? Does it then make sense to sort of combine these two functionalities into one package, let's say a patient plus auth or something along those lines? And finally, we also need to discuss about transactions, right? We're creating enterprise applications. We're absolutely fantastic engineers. We want to give our users the best of experiences while still maintaining some form of technical compliance, while still ensuring quality and minimizing errors within our application. So transactions would be one of the key things which we discuss, right? One of the things which we absolutely have to use. So what about that? How do you do transactions when it comes to a microservices where you have 7 different services communicating with each other to do one single job? You consider something like an Amazon. You have a service which displays the products, a service which gets the product details, another service which will handle the cart, another one handle the orders, payments, dispatch. If something goes wrong in this entire transaction cycle, how would you revert everything? How would you go about changing whatever piece of data you need to change to reflect the latest status, right? Or if something inconsistent happens in your database, how would you ensure that inconsistent state change is not persisted in your data engine, right? So that's where we get into transactions, and we will then sort of expand our conversation into distributed transactions. We'll have sagas and a lot of different things which would take a lot of engineering effort, things which would take a lot of managerial effort, and things which would take a lot of cognitive effort to think about, to reason about, and finally to build, deploy, and test. So, okay, all of that aside, we have now built everything, right? We have 7 to 10 different services lying in our data center. They're running on AWS. Everything is absolutely fantastic, right? Like we have them with us. How do you go about thinking that, okay, AWS is our cloud of choice? How do we deploy this in the first place? And a couple of conversations sort of sneak in here. How would you route different requests to the correct microservice? How would you handle authentication within the services? Like, let's say a standard user shouldn't be allowed to access billing details, right? How would you handle that kind of authorization mechanic within microservices? You have one service, but now it needs to add another layer in front of every other service to essentially do fine-grained access control or role-based access control or whatever you have in front of you. That's where we get into another territory of deciding and defining what is a decent job here. Can we just, put a shell script and deploy everything all at once, or do we need to figure something else out? When I say DevOps, there are a couple of things which come into mind. What kind of API gateway are you trying to use, which is essentially how you route requests to the service which will handle them. Like, for example, /user would be the user service, /auth would be the auth service, so on and so forth. If you have deployed or if you have chosen a specific API gateway, how would you configure it? There are tons and tons and tons of examples. And just to give you a very simple idea of how big this space is, if you Google right now CNCF landscape, if you open the first website which is, I think, so landscape.cncf.io, you will see the sheer amount, the sheer number of services which are available to you at this very moment. There are at least 5 different API gateways I can name. There are 3 different distributed configuration stores. Configuration stores to hold key value pairs, essentially, you can think in a way. How do you make the decisions? You understand the kind of cognitive overload you have had to undertake in the first 1 week of deciding to go with microservices at whatever stage within the journey. And before we get into the solution, do you folks have any questions with all I have said till now? Like absolutely anything which comes to mind here?
I think we have one question already, Shreyansh. Can we take that? I think it's from Devang.
Right.
And he is asking how to define up to what level we can keep the app in monolith to convert into the microservices.
I'm sorry, can you repeat that, please? How do we decide to what extent?
what level can we keep the app in monoliths to convert into microservice?
Okay, so if I understand the question correctly, it is when do we make the decision of going from a monolith to a microservice? So Devang, that's actually a great question. I would probably want to answer this at the end of this conversation, because right now we are not discussing how do you go from a monolith to a microservice. We're saying let's completely skip the monolith stage in the first place. Let's directly go with microservices. I'm trying to explain how when you make that kind of decision, there are certain additional factors you need to account for. With the question you particularly asked, that is something which we'll be delving with, but towards the end of this conversation. So if that's all right, I'll probably answer it in a while. I see another question from, I think so, Vinayak.
Yes. Yeah.
How to put authorization amongst these 7 to 8 microservices properly. All right, so that's actually a very decent, very nice question. And I'll answer this in 3 different stages. The simplest solution, which doesn't really offer you a lot of flexibility, but it does get the job done as quickly as possible. The second, which is sort of a compromise between managing these services and developing these services. And lastly, something which is slightly more complicated, but is infinitely flexible. So at the most primordial level, the simplest way of putting authorization would be to essentially use some kind of role policies, right? Which would basically mean that, like, let's say you have your authorization service, and that would expose some form of a server to server or a service to service communication API, which will contain that, like, let's say user Vinayak is allowed to execute these actions because he falls under this role. That one role can be, like, let's say admin. So you can predefine that an admin can do absolutely anything. Right, this is the simplest thing to do. You can then have like multiple roles within that. Like, let's say you have an owner, an admin, a billing admin, a user, etc., etc., etc. Whenever you get an authentication token, whatever authentication token you guys are using, like it can be an opaque authentication token, or it can be a JWT or whatever have you. The requests are then forwarded to the authentication and authorization microservice, which would in turn reply with either an unauthorized error, or it'll just let the service communication go through. Something which does this quite fantastically is an API gateway called Traffic, TRAEFIK. And what these folks allow you to do is they allow you to build your own very, very tiny service, and they allow you to send them a token, and based on the kind of response, this HTTP status code you send, Traffic will make the decision of whether or not the request should go through, which makes your job very easy, because you don't have to figure out how would you send the data, how would you get that data back, how would you forward all the request parameters correctly. For example, if you have a redirect in the request, this becomes especially tricky. So you can use a nice API gateway like Traffic for that. At the middle layer, you can take this a step further by defining resource-based access control, which would essentially mean that every role would have a policy, and every policy will have a certain set of actions. So for example, let's say you have a entity called a user, right? It can have, let's say, 4 operations: create, read, update, and delete. You can say that an admin policy contains, like, let's say, user star, which means that you can do absolutely anything to the user. It can be billing read, right, which means that you can only read the billing information as opposed to updating it or deleting it. What this the downsides, of course, are that it requires a fair amount of understanding of the kind of data you have before you even get into this. So it brings your overall velocity slightly down. But what it offers is quite a nice amount of flexibility, where you can do quite a lot of cool things as and when your application gets slightly more mature or complicated, because you have defined these, like, essentially like these open policies. Taking it one step further, probably one of the most complicated solutions to this, but something which you would see in like a fairly let's say mature service stack, is some form of a policy engine or a rule engine. It would contain 2 things. It would contain a policy. If any of you are familiar with what AWS IAM is, so you can think of policies as like essentially JSON documents which contain what all you can do, what all you can't do, right? Coming I'm sorry, depending on where the user is coming from. So you can create these basic policy structures. You can define it in your own rule engine, for example. And what you can do with this is that you basically have an absolute infinite canvas to experiment with. You can define things like, if the HTTP request path is X and user's ID is this, and they're not a member of this group, and they haven't made these many requests, then only deny authorization. Right. So you can do something extremely complicated, something you might require, particularly with compliances. And again, the reason why it's complicated is because you have to implement your own rule engine. However, one thing I would recommend is to look at something called Open Policy Agent, which does the entire rule engine part. You can write these policies in something called Rego, which is OPA's language, Open Policy Agent's language. And you can embed that within your own stack and get all of that done. So I hope that answers your question here. Yes, it will sit between the rule engine. It will sit between the microservices. Yes. So essentially, the way this would work is that let's say a request comes, it hits your API gateway. The API gateway does the first thing of forwarding, let's say, critical security parameters to your authorization service, which can contain a module called a rule engine. So requests will be forwarded there first, and depending on the reply, we'll take them again, if that makes sense.
We do have few questions, Shreyansh, but do you want to continue with the presentation and then come back?
I would love to answer the questions first. Yeah.
Okay,
great.
I think we
technical
have
question.
Actually, he's asking where we could get the recorded for reference. Okay. For people who are listening to us, we are actually live on LinkedIn and YouTube. So if any of your friends want to watch the live, or if you want to share, for the people who are joining on Zoom, please, you can share and refer the live link of our Recro's YouTube channel or LinkedIn channel, and we'll be live over there. And you can just go anytime and just rewatch the live already. And then we have next question is Vinayak, and he's asking about what will that policy management rule engine will sit between microservices.
Yeah, I already answered that.
Okay, great.
Yeah, we already took that. Yeah.
Okay, now I don't think so we have any more questions. I think we can go ahead with the presentation.
Perfect. Right. So we've discussed all of this, right? We've discussed how complicated it is to get started with microservices, right? And when you don't really have at least let's say 2 to 3 people helping you with the entire implementation, taking care of DevOps, taking care of the actual engineering behind the application, it becomes very overwhelming very, very quickly. And this is something which I have seen happen at a lot of companies. So before we discuss the solution, what I would actually want to sort of discuss a little bit more would be, when a new startup comes in, when you have a new business idea, right? As engineers, our responsibility is to implement that figment of imagination, that thought someone had, into an actual product, into something which users can experience, something which they can use, something which will hopefully help them with a problem they're facing. And that I feel is beautiful, right? But there are a couple of meta discussions you need to have there, right? One of the first ones is that as a startup, what is something you value the most? Do you value velocity the most? Do you value how quickly is it that I can get something out? And for a lot of startups, for a lot of companies, for a lot of products, that's extremely important. That's imperative. It's a necessity to an extent. Why? Because you haven't found a kind of a product market fit within the community, right? You don't know whether the problem you're solving right now is an actual problem worth solving. Is this something which the users will like? So as engineers, what we need to have is the ability to very quickly run experiments. What is the simplest, what is the quickest way of running something, of building something and getting it in the hands of my users? The more you dabble in technology, the more sophisticated systems you start building, I would say that sort of goes into the line of over engineering. You don't need them to create what I call a MLP, a minimum lovable product, something which people genuinely enjoy using, not a minimum viable product like it is on paper, but a lovable product that, this is application X. I genuinely enjoy using it. These are my thoughts. It's not polished. Go for it. I'll continue using it once these problems are fixed. Once you find that kind of fit within the market, that's when you want to focus on the kind of experiences your users are having, how dependable your system is, what kind of corner cases can it handle, what kind of, and as you, of course, grow bigger, you'll have GDPR and you'll have 1,000 different compliances. So that's where it sort of, makes sense in a way to go for something which is slightly over-engineered, which has a lot. I wouldn't call that over-engineered. I would call that like properly engineered. Because again, engineering would depend on the context. But you see how when we have more things to worry about, the quicker result that we want to at least, get something out, just see what people are thinking about what we're building, because you don't want to spend 12 months building something which no one enjoys, right? That's where you go with basic solutions. You go with the absolute first principles of engineering, the most basic solution you can think of. You don't have to polish out every single thing. Let that be an iterative process. That's the baseline thought I have when it comes to building something. Finally, let's say you are at a stage where, you're thinking that, like, let's say you're building a fintech, right? And fintechs have a decent number of compliances you need to get done before you even get started with something, right? You have a lot of liability, you have a lot of risk which is associated. You can go with one of two ways. You can get a lot of things done on paper and, pray to God and hope everything happens. I've seen that as well. Or you can, sort of take some extra time and figure out what exactly is the best approach to go with, given the requirements at hand. And that is where I feel a service-oriented architecture, SOA, sort of makes a little bit more sense. So SOA is, you can think of it as like sort of an umbrella on top of microservices. Service-oriented architecture essentially deals with any sort of application architecture where entities are services, right? They're handled by services. Now you have a lot of patterns within that. One of that pattern is the microservices pattern. You also have nanoservices. An example of a nanoservice is that instead of doing CRUD on a user, you'll only do create on a user. That's a nanoservice. But going with a service-oriented architecture, sort of taking a step back and seeing what the bigger picture is, makes slightly more sense, because there you can make a decision that, this is that one particular thing. Going back to the example of a fintech, you would have compliance around how you handle card data, how you handle personally identifiable information, etc., etc. That would require a lot of guardrails, a lot of logging, a lot of auditing, a lot of monitoring. That is something you can probably extract out into its own service, right? You can merge them. You can create one service which is handled for which handles the critical aspects of your entire journey. That makes compliance a piece of cake. If anyone is familiar with something called PCI DSS, we have done this at a fintech which required PCI DSS right from the get-go. So we did have to sort of, engineer it slightly more than I would have personally liked. But what that meant was that additional 1 or 2 months of effort meant that we were live ASAP. Our compliance got checked off in the first go, which is fantastic. We didn't go with microservices. We went with something in the middle. You have 2 monoliths because they are divided in 2. They're not as heavy as one would be. There are still certain considerations around how you transfer data, around how you store data, around how you handle transactions. But this is where you need to sort of make those decisions, because this is something which is imperative for you to essentially deploy. What this also means is that you are easing into the process of creating an extremely complicated service stack, because you only have two fairly chunky services, right? And what that would essentially translate into is that you don't have a lot of CI/CD documentation. You don't have a lot of CI/CD scripts which are running in the background. You don't have to figure out how would an engineer just download everything and get started on their work, because these are just two services. These are just two code bases for you to handle ultimately, right? So that's my thought. So that's my thought when it comes to figuring out a nice solution between the two. However, the first thing, go with the monolith. If you require a certain amount of compliance, if you require, some of the benefits you're getting from microservices, probably try figuring out how can you fracture your monolith into two, which would give you some of the benefits which a lot of people enjoy with microservices. And ultimately, we come to microservices. Now, this is where I would discuss a lot of different things of where it makes sense to use microservices. But before that, let's take questions. I see there are 7 questions, if I'm not wrong.
Yeah, I think the above questions, I think we already answered. And after that, we have a question from Ayush, and he's asking, what are the different ways to communicate between microservices other than the RESTful APIs?
Right. So what are different ways of communicating between microservices apart from RESTful APIs? So there are a few tools you have in your arsenal. Essentially, what this translates into is what kind of communication substrate or the material or fabric of communication you want to use. The simplest, like I said, is RESTful. A couple of other things you can think of using is JSON RPC. We generally use RPC when we want like Ethereum, for example, uses RPC, which is a remote procedural call where you have just one endpoint which does literally everything. That's a very basic definition of what it does rather than what it is. But there is an example of using a JSON RPC communication substrate. You also have something along the lines of what do I call them? Structured encoding format would be the best way of saying what it is. So an example would be like, let's say, message pack or protocol buffers. I personally prefer protocol buffers, but what message pack would offer you is a more compact way of representing whatever data you have in a binary format. So it's not as big as JSON, but it's not as small as true binary encoding. JSON RPC, sort of falls into the decision paradigm of thinking about how that actual service works as opposed to how does it communicate with one another. But RPC in general are one of the ways we use we think about communication. Another example is gRPC. So you have gRPC, which is Google's answer to how RPC works. It's a tried and tested way of doing things. It works fantastically with protocol buffers I was talking about. The reason for that is that protocol buffers allow you to have static typing for your messages, which means that you can define that when someone sends me X parameter, the type has to be like, let's say, an integer, an int 32 or a floating point a number or something along those lines. It also makes backwards compatibility, which is absolutely imperative in microservices, extremely easy. And finally, it gives you a fantastic performance when it comes to encoding things on the wire. Ultimately, when you talk about gRPC, which is the way the communication works as opposed to what the language of communication is, that's where it offers you a lot of other benefits over REST. So traditional REST isn't truly bidirectional. You can use protocol negotiation and go to something like a WebSocket, but again, that's a different story. What gRPC offers is bidirectional streaming. So if you have something which depends a lot on streaming data, you can sort of get that done with gRPC quite well. And secondly, you have a lot of code which is also generated with gRPC, or rather a lot of RPC frameworks do this nowadays, starting with gRPC, where they generate a lot of service definitions for you. which means that if you're a fan of, ensuring that one schema sort of translates into how services are written, going with RPC would be the way to go. Other ways you can sort of communicate would be your, web services. Definition, or even to an extent SOAP, which comes under your like fairly enterprisey, fairly legacy WSDL definitions, which is how services written in Java Enterprise used to work at a point in time. So you have like a couple of options in front of you. I hope that answers your question.
Yes, I think we have more questions, and we have something from Vinayak, and he says, I would agree with you completely, and most of the founders does this nowadays, and it becomes risky when the same velocity gets as usual expectations from the founders later on, with number of customers coming in, and then the engineer get devalued later, and provisioning customers is because more preference. How to overcome this, or what would be a good time to relook on the engineering service?
All right. So if I understand your question correctly, you're asking what would be a good time to sort of understand when do you need to change your engineering practices when it comes to deploying and developing features? Am I right? Feel free to just use the chat to give me your question. I'm sorry, I'm a little confused with what exactly you asked.
I think we have another question from Vinayak itself, and he's asking if we want to communicate among services, if this is unidirections, we can use quiz and PubSub approaches as well, right? For example, Kafka and Redis.
I would sort of disagree. No. So PubSub means publish and subscribe. So that is real-time communication. We are not talking about real-time communication, right? We're talking about unidirectional synchronous communication during which, after a transaction is done, we close that communication channel or the transactional channel in general, which would essentially mean that, let's say, if you want to process a payment, that's something which you have to do immediately while the customer is waiting for you. That's where you can use that's where the transaction would end the moment the payment is verified. If you want something of a side effect or something you want to process when the user has had some time, when your systems have had a decent time to, let's say, reduce the load or whatever it may be, that's where you would get into queues. So you have synchronous communication, which is, I ask you a question, you give me the answer. So the client asks the server question, the server immediately responds. That's synchronous communication. That's what we usually create with APIs. Then you fall into asynchronous communication, which is, I ask the server a question, a client asks the server a question. The server says, I will reply when I want to reply, right? You don't care about the reply right now. So yeah, I'm busy, let me enjoy, right? That's what the server does. That's where you get into something like using a queue, that you have something pushed to a queue. Like, let's say you bought something, sending an email takes a fair amount of time. Why do you want to burden your server with that, right? So let's just push it to a queue. Whenever our consumers, whenever our workers have the ability to take this message, they will do it. So we usually do that for processes, or for sub processes rather, which don't require either immediate or instant gratification, one, or two, are not the happy or the critical path of the system. For example, if an email fails, if it's usually it's not that big of a deal. Sometimes it is. That's when you get into prioritization, but usually it is not that big of a deal. So let's pop that over to something else. PubSub would more be along the lines of, if you had, like, imagine in a very simplified way, if you had one queue and you had multiple listeners, right? So that's where like Kafka and essentially like stream processing systems really sort of shine. which is, let's say you made a transaction somewhere. We have some information. Now we want to know what is the logo of the merchant outlet where you made that transaction. So adding all of this information is something which stream processing can do quite nicely, which PubSub can do quite nicely. Batching is also done in that regard, right? So if you have one listener, usually we use dead weight queues. If you have multiple listeners, we would get into some form of a subscribe to all or publish to all kind of communication channel. Does that answer your question?
Okay, I think he's saying yes. Great.
Right.
So next question. I mean, when is the good time to move from MLP to microservices?
To microservices. All right. Okay, got it. So I don't have an answer for you for that, because it truly depends on what is it that you're trying to build. There isn't a one size fits all, sadly. So an example I can give you is, like, let's say you've built an MLP, you've built a product which is loved by users, something which is loved by, let's say, your investors as well, by you, by everyone on the team. Fantastic. Now we need to take it to the next level. You've figured out what kind of features people are enjoying. So let's double down on those features. With that, you also figure out that we need to do, let's say we want to expand to international markets, we want to do GDPR, or we want to do something along those lines. That is where going into some form of service-oriented architecture would make sense. The other reason, to specifically answer your question, to microservices, usually we do that when we have cross-functional teams. And so I talked initially about how microservices, the reason for choosing, or the reason for going with microservices 99% of the times, isn't really technical. It's more organizational. This is the reason I was talking about, that microservices should basically reflect the organization of how your microservices are, should reflect how your organization actually is, which means that, for example, if your engineering team has, like, let's say 10 sub teams, there would usually be around 10 services. Each one of those teams would be responsible for managing one of them. Which would make a lot of things sort of isolated, which would mean that you have their own, they have their own sort of deployment strategies, that they have their own set of tooling, they have their own everything else, right? So they are this one block which works with everyone else, and they release contracts which are then consumed by 9 other services, for example. That's where it would make sense. Finally, where would it make sense to go with microservices from the beginning? There are very, 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 very few cases where that does ever happen. But if you know that you are, like, let's say, migrating from version 1 of a project to version 2 of the project, and there are certain data characteristics and requirements and data flows which don't really work that well with what you had previously designed, but you can work with them in a much better way if you had some form of async processing. And again, given you have a fair amount of time, you can go to microservices. Again, that's just like one very basic example of something I have done in the past, something where the requirements existed, that, you know, we can now go with microservices because, one, we have the people, and two, we have an actual requirement. I hope that sort of answers it.
We do have
product
questions
is working. Yeah. Sorry.
I think we can go with this question, and after that, we do have questions from LinkedIn.
Right.
After that, we can
Sure.
take these questions.
Sure. So, Sujit, I'll just answer your question. Vinayak has asked a follow-up to what he had previously asked. So he said that that is why I asked the first question, that for a founder, if product is working, why and when they should look for an engineering relook. Okay, got it. So when they should look for an engineering relook, when whatever strategies you had in front of you of deploying and developing services or products or features in general is not working anymore. An example would be when a product usually starts out, you won't have a very well-defined change management process, which means that you don't have a very well-defined way of auditing when a specific feature change was made, either added, updated, or removed. Without, you know, sort of really going into the code and figuring out, you know, this is where they've removed this chunk of code which did X feature. So when you want to move from that to a level of maturity that, this is now when I need some amount of let's say, auditability or something along those lines. So you see how processes have changed, where once you were just thinking of something in your head and you were just building it out, seeing how the people liked it. Now you have a proper formalized approach to this entire process. Like you might have a product manager coming in, you might have other teams sort of coming in. That is where you would look into a sort of redoing your entire engineering strategy. That is also where like, for example, when you see a new startup, you won't really have like a lot of titles and positions, but as they sort of grow in size, that's where titles and positions and essentially delineation sort of come into the picture. Why? Because you need to now have one person who can focus on, like, let's say the biggest picture possible, which is the business and the tech alignment. So you have a CTO, someone who can execute things on the ground. So you have a VP of engineering, someone who can handle, like, let's say, just DevOps and systems administration and platforms engineering. So you have a director of PE, a director of systems operations, etc., etc. That is where you would have an engineering relook. That is usually also when you're changing these practices and processes. You would realize that certain parts of the system which I created, like, let's say, a year ago, are not working out anymore. We're facing a lot of issues in doing X, Y, and Z. We have tried out like 3 different things. They haven't worked. Now we need to sort of relook into this entire data architecture to begin with. So that's when you would do it and why you would do it. I hope that answers your question.
Do you have any more questions? I think we kind of missed one question, Shreyansh.
Yeah, we from Sujit, right? So Sujit asked, Java-based microservices are having lesser scope than front-end projects. I feel that's not a very correct comparison. Java-based microservices having lesser scope than front-end projects. I mean, not necessarily, not really. I wouldn't say that's the reason why I say it's not a correct question is because those are two inherently different things. Where one is, very traditional backend engineering and architecture, and the other one is, well, front-end engineering. So I would probably say that both of them are different in their own regard, and they are quite absolutely fine where they are right now in the market.
Okay, so let's go with the live questions. Just let me have a look and then. Okay, so one question is, how much effect does it make if UI is not designed well with low-key system design?
I'm sorry, I don't understand that question. What? Can you please go over it again, please?
Okay, how much effect does it make if UI is not designed well with low-level system design?
Okay, so you're asking what kind of effect would a process in which we're designing the UI without low-level systems design, how effective that would be?
Yeah, I think that's what he's asking.
Okay. Yep. Right. I mean, those are two completely different things. So usually when we start a product, we don't start with data design. We usually start with user interaction and user experience design, which is where you would have, of course, all the buttons and everything, like you said, but you would also think about how the user goes from page A to page B. What kind of friction does the user face while they're doing that, right? So you can't really do LLD or HLD till the time you have UI UX in front of you. I would sort of argue that it makes my job as a backend engineer really, really easy if I have the end goal in mind, because I know what kind of expansions I can make later down the line, but it also tells me what is the absolute baseline I need to provide to my clients. It also makes communications and let's say cross-team collaboration between front-end, back-end, and platforms engineering quite easy, because you have this one source of truth, which is essentially your user interface, which cannot be changed, right? So everyone knows what data the front-end needs, what kind of deployments the back-end would want to do, what kind of database the back-end would want to do, or what kind of expectations the front-end has on the actual data. And how would data go from one place to the other? Everything you have over and above this is something which we handle in data architecture later down the line. But I would say you usually do UI before you do LLD. So I hope that answers what you were asking.
Yeah. And one more question, and it says, how can you monitor and troubleshoot issues in a microservice-based system?
How can we monitor issues and troubleshoot problems in a microservices architecture?
Yeah.
Right. So that's a fantastic question, because I have had a lot of experiences in racking my head for like 5 hours before we had these like really fancy tooling available to us. But in general, I would say, again, think from first principles, right? When you think of ultimately what microservices are doing is that they are communicating with each other, they are interacting with each other to do one particular transaction. That transaction can be like, let's say, signing a user up. And what I would do in this particular example is that I would say, let's say there are 3 stages to creating a user. You create the user in the database, you store some information, some hashed information about their security parameters and credentials. And finally, you send them some email that, like, welcome to Recro, for example, welcome to the community, for example, what Discord does, right? So you have 3 basic stages. To do this from A to B, to do this from start to finish, essentially, you have these 3 things you need to do. Let's say these are handled by 2 services. User creation is handled by your user service, and sending an email is handled by your email or communication service, usually. We now need to figure out if there were issues, right? So what I would say is you break this transaction down into 2 sub-transactions. The first sub-transaction is, let's say, inserting that data in the database, right? The second sub-transaction can be publishing a message on a message queue. Again, I think so Vinayak sort of asked this question, can we go with Kafka or Redis or PubSub? So this is an example where you can, where you send the user details, which the communication service will then pick and send an email, which can be another sub-transaction. Now, for you to figure out whether there are problems with, like, let's say, service A, B, or C, you would need some form of insight into what they're doing, which is where I feel something like a distributed tracing framework like Jaeger or Zipkin, I mean, they used to be the previous versions, really sort of they come in, right? What they do is that they give you this insight with very little effort, right? You have to write like a few lines of code, 2 to 3 lines of code or 4 lines of code to add this information in a very nicely and neatly presented chart. And you can then, sort of click on these chotu transactions, these small transactions, and figure out if any of them failed. If you take it a step further, you have different API gateways which do this at the service integration stage, where service A is communicating with B, is communicating with C. An example which comes to mind is Istio. It's not the simplest platform to adopt immediately if you don't have any prior experience with Kubernetes and everything else. But what it offers when it comes to debugging and troubleshooting is fantastic. It allows you to look into visually what path of a transaction is failing by just looking at its dashboard, right? So that's another way of getting into it. And ultimately what would happen is, so you have now figured out that, like, let's say the problem is in service A or service B or service C. You would have some information which has been logged, like, let's say, a transaction ID or a correlation ID. You can then open your logging application or logging platform, enter that trace ID, and you will get all the logs there. That's what I usually do. That I would have a transaction ID, a request ID, which is different for every microservice, and I would have a correlation ID, which would remain the same across a transaction, right? So every sub-transaction would have its own request ID, but they would have the same correlation ID. So that way I can correlate logs also, right? And I would then see what issues exist within that particular service, or what happened while, sending an email to someone. So that's that. If you want like a low-key method of doing this, like a very simple method of doing this, you can just print out logs with like a transaction, a correlation ID, and just gather those, and something like Elasticsearch does this for you. But you'll have to do some trickery with the log streaming, so that all of the logs are condensed in the same place.
Yeah. I think we just have a few more questions, and for the people on Zoom, if you are having any questions, We're almost on time, but we'll be taking up last questions, like few 5 minutes questions. If you can drop down quickly in the Q&A tab. And Shreyans, I think we can stop the presentation.
Sure. I mean, I can't. Oh, guys, I'm sorry. I forgot to say thanks. Feel free to give me your questions. Right. Okay.
Yeah.
I think I've stopped screen sharing now. I think so.
Yeah. And so we have one more question from live, and it says, how do microservices impact system scalability and performance?
How do microservices impact system scalability and performance? Can you define a question slightly further? Because the general thought process has been that microservices give you better performance and better scalability. Better performance, why? Because you now have one service which is like, let's say, running on some form of a distributed cluster compute machine, like let's say a Kubernetes or whatever you have, right? In its own independent state with its own independent internal data, right? Which is not affecting anything else around it. So usually that is better for performance, right? You can individually scale everything, and scalability sort of ties into that. Now, because you also have a specific service for a specific job, you know that, like, let's say if it requires extremely specific hardware capabilities, like for example, you have seen all of these testing platforms which do browser testing in the web, right? On their own page, they need to run Selenium, right? How do you virtualize a virtual machine? Right. So you would now say that, I've created one microservice which can only run on bare metal instances. So you have great flexibility when it comes to doing that as well, right? That you have already isolated and let's say sort of bounded so much of that context that you can now choose and pick wherever you need to deploy this or whatever specific resource constraints these functionalities have or would consider to function properly. So I would say that's the kind of deal. Negative side here, you really have to do a lot of figuring out before you get into this realm. Like, for example, what I said sounds quite easy to do, but you would have to get into node affinities and anti-affinities and labels and a lot of different things. And then you would have to deal with AWS billing. And I did like 4 years of college figuring out how to do math. I still don't know how AWS billing works. So that's the kind of deal you have to do, right? So, ups and downs.
Yeah. I think one last question, and it says, how can you ensure consistency and coherence across different microservices?
How can we ensure consistency and coherence across different microservices? So can you define consistency and coherence? Like, in what way are you using those words here?
This was the only question I think we got. Yeah, I did not well down into that more, to be honest.
So if I understand consistency, I would imagine you're talking about data consistency. If you talk about how data remains consistent across microservices, that itself is a fairly vague discussion. But the simplest way to tackle it would be, like I said, transactions, if that makes sense, because you have a lot of definitions of consistency, right? If you have, like, let's say, consistency talking about how do you upgrade from, like, let's say, microservice A version 1 to version 2. How would you ensure consistency there? That would be how you handle consistency and backwards compatibility within the data layer. If you have consistency across transactions, that would be, well, distributed transaction sagas and, two-phase commits and all of that jazz. If you talk about consistency in communication formats, in communication substrates, that's where you would go into protocol buffers, and that's where you would go into numbering each of your fields, which is what protocol buffers do, by the way, to ensure backwards compatibility. So consistency, I would say, is sort of a vague term. If you can define it a little bit more, I would be more than happy to answer that. Coherence, I don't understand. Do you mean consistency when it comes to writing the application? Like, how do you ensure consistency in how the code looks? I'm not really sure. Just define it a little bit more and I'll be more than happy to pick it. There's one question here, Anshum, from Sujit. So he is sort of, reframing the question he asked. I just want to know if APIs are common while front end. If is APIs are common while front end is at mobile, web, and desktop app. So is trend going to the front end side as there is more development required? What is your opinion? Okay, so you're saying that because they are just APIs, is there more scope in APIs, or is there more scope in front end? Because there are like, there is web front end, there's mobile front end, there's a, desktop front end, so on and so forth. I would say if you fracture down, or if you, sort of boil down what APIs or backend engineering essentially is, backend engineering and front-end engineering can be compared. API development and front-end engineering cannot be compared, because that's like saying, what is the difference in scope between a web development versus backend engineering, right? Because these are two completely different terms at two completely different levels. So within backend engineering, you would have, API development. It's one of the jobs we always do, right? Within front-end engineering, we do a lot of other things as well. So mobile, web, desktop, optimization, figuring out, giving a great experience to users with, like, let's say, lower network bandwidth, et cetera, et cetera. So I would say there is a decent amount of work which is involved in both of these fields and disciplines to create a fantastic, a loved product, right? So I would say there isn't any trend, at least in my personal opinion, which is going towards one side when it comes to developing these things. Now, of course, people are making tooling, which is sort of easier for someone who is new to tech to build applications more quickly. Or they're packaging, more features together, in a nice, neat little Bohr app bundle. But that is something which we have seen in the industry for a while. There was Meteor, which did isomorphic backends and front ends. Very recently, I think so, Remix is doing something along similar lines. So that is always there. But when it comes to more scope, both of them have a lot of things you can do. So that would be my answer for that here.
Yes, I think that was the last question. And if you guys are having any questions, we'll just take one more minute. So quickly drop in your questions, guys. And I think we'll be, okay, we have one more question from Vinayak.
Vinayak was an absolute fire today, man. But I'm absolutely glad, Sujit, Vinayak, everyone who has asked me questions. This is what I love doing. So yeah. So the question is, so far we've been building single APIs for web and mobile. Do you think there should be separate in terms of data? Yeah. I would say in certain instances, yes, it makes sense to build a different API. But then again, think about it. When you're building a different API, you are rewriting a lot of code, regardless of however modular you can be, you're still writing a lot of code. In terms of what exact data parameters you want to extract, right, from the data you're getting, I would say that can boil down to how you do things at the API response format. And a great example of this, I would say, is the JSON API specification. So the JSON API spec, if you Google it, it basically says that give the minimal amount of data which is a cross between all your platforms. Like, let's say your desktop requires your first name and last name to render a page. Your mobile requires first name, last name, and email. So my backend in the first default response would send first name, last name, and email. It's one additional data field, but data is now cheap. So we don't really care about it that much as we used to, like, let's say 10 to 15 years ago. The second thing we get into is that what if you want more information about the user? Like, let's say, what if you want the gender, the sex, what if you want the age, the date of birth? That is where you can make the APIs accept more information. Like, for example, they can have an include parameter, which would then respond with the additional fields you have requested. So that way you're sort of killing two birds with one stone, right? Where you have just one API, but it can filter out the data. Another example would be going into GraphQL, but I wouldn't really recommend that for this kind of a use case, because one, it's more engineering effort. There is some code generation, but even then, it's new technology, new concepts you have to wrap your head around. Still, you have to write some code. So I would say steer clear from there for something like this. But yeah, if it becomes like huge, then GraphQL would be your buddy. So that.
Yeah, I think that was the last question. And well, that brings to the end of this wonderful session. And I would like to thank each one of you for joining us. Hope you learned something new from today's session. We will look forward for your post on your LinkedIn, and please fill out the feedback form that I dropped in the chat. and let us know what did you like the most and what's something that you're having a takeaway from the session today. And we had an amazing presentation, Shreyansh, and I think most of our audience, half of the presentation was just driven by the questions from our audience, which I really appreciate. And don't forget to tag Recro, tag Shreyansh, and tag me on your post. And if you want to have any advanced version of this topic, or if you want if you want to listen to any other versions on the same micro frontends or system designs from Shreyansh, please do drop me your suggestions on LinkedIn, or you can reach out to Shreyansh and he'll be more than happy to help you. Right? And also, thank you so much, Shreyansh, for joining us. Thank you for taking out time and presenting such an amazing presentation. We had an amazing time, and thank you for sharing such insightful information.
I'm glad to have helped absolutely anyone, and of course, thank you so much, Anjum, for calling to this platform and allowing me to like speak for like an hour and a half. It's been fantastic. But in general, I would really like to thank everyone who joined in, everyone who asked questions, everyone who learned something from this. Right. A lot of what I say might be like outdated in the next 1 year. That's how quick tech moves. But in that time, I've given you my socials. Feel free to like harangue me with questions. Yeah. I would be more than happy to answer whatever. I'll build a social media presence that way at least. But yeah, thank you so much for this. This was a lot of fun doing. And
yes. Yeah, and before we end this session, I have a few announcements to make. We have created a community for developers called Rebase on Discord. Join our close community for JavaScript developers to unleash your true potential. So if you're a developer of 1+ years of experience, you can join the community, connect with the experts over there, and you can reach out for collaborations, connections, and interactions over there. So the link of the community is in the chat, so you can just go ahead and join the community by filling up a basic detail form. And I've also dropped a feedback form, just another reminder, guys, and please make sure that you fill out the feedback form and let us know how did you like the webinar. And if you have any questions, you can follow and connect with Shreyansh. I'm going to drop his LinkedIn link in the chat, and you can go ahead and follow Shreyansh, and he'll be more than happy to help you guys with the questions and any challenges that you're facing. And obviously he loves teaching, and that's something that he really takes pride in, and he'll be more than happy to help you guys. And
so just to add, I'm so sorry, go for it.
Yes, you were saying something, Shreyansh.
Right, no, I was saying that on Rebase, I'm sort of mentoring as well. So if you have any questions, feel free to hop in there and pop in a question. There are a lot of people like me who really like talking about things and really like teaching. So it would be a fantastic platform for everyone to connect with people who are like much smarter than me. So you can just imagine what that would be like, right? Yes. So feel free. It's a fantastic place to.
Yes. Yeah, thank you so much for that. And if you're exploring career opportunities, Recro is hiring passionate developers. Check out the current openings at Recro. And if you have any friend, family, or a colleague who's looking out for a change, we'll be more than happy to place them in the great startups of the country. So you could visit the link I've dropped in the chat, which is recro.io/careers for the people who are watching us live. You can go ahead and explore career opportunities, and we'll make sure that we'll place you in the great startups of the country. And to stay updated with such events, follow us on social media, follow us on Instagram, YouTube, and LinkedIn. And the recording of the session will be live on YouTube and LinkedIn, guys. So please hit a follow and watch the webinar. Again, if you've missed out any points, and if you want to note down some points that Shreyansh has mentioned, and you can share the webinar too with the friends and colleagues if you find this interesting. So that's all for this session, guys. Thank you so much for joining us. Hope to see you in the next session. Take care. Stay safe. Thank you so much. Thank you so much, Shreyansh. Thank you.
All right, then. Thank you so much, Anjum. Thanks a lot, community. Bye-bye.
Yeah. Bye-bye.